Chapter 4 starts on page 73. That is where you will find a lot of definitions for your terms this week as well. So we're going to get into the different measurement systems that we see being used in the pharmacy and then how to convert between all of those systems. So chapter 4 is just an introduction to all of these systems here. So we have the U.S. customary system, which is also known as the household system. So these are going to be units that you use typically in the kitchen when you're cooking. So we're used to those here in the United States, units such as the teaspoon, tablespoon, cup, etc. The international system, most of us know this as the metric system. This is going to be the most commonly used system in the pharmacy. That's because it's the most accurate system and it is used worldwide. And then lastly, we have the apothecary system. So this is the oldest system of measurement. We don't see this used too much anymore. However, some drugs are still measured in these units today, which is why it's important for us to go over those as well. So starting with the household system, like I said, we are probably the most familiar with this system because we live in the United States. How we write these units, it's always going to have the number coming before the unit, which you'll see why I am making a point of that for this system in a little bit. Anytime you have a measurement that is less than 1, make sure you notate that with a fraction rather than a decimal. So we always use fractions in the household system. Usually we don't see this system used in the hospital setting. However, you do still see some physicians writing medication orders for liquid medications using household units. So we're going to need to know how to quickly convert that into metric units. So usually we're going to be going from teaspoons and tablespoons or ounces into milliliters. So if you turn in your book to page 77, there's going to be 3 tables there that are indicating the units of weight, length, and volume for the household system. We typically don't see length used too much in the pharmacy. Occasionally, we may need a patient's height if we're considering their body surface area, or we may have to do like a calf measurement or a thigh measurement if we're fitting, compression stockings for diabetic patients or something like that. But typically, we're going to be using units of weight and volume. The metric system, if you turn in your book to page 80, we have a good table here that has all of the metric units that we will be seeing. So the most common unit of weight that we'll be using is probably going to be the milligram. We see a lot of a lot of medications measured in milligrams. So the base unit of weight is going to be gram. Like I said, typically milligram. We also see microgram quite a lot. Occasionally we'll see kilogram if we have to do a patient's weight conversion from pounds into kilograms. And then the most common unit of volume that we'll see in the metric system is going to be the milliliter. The base unit of volume is the liter, but however, we typically don't tend to work with that large of volume, so we'll see milliliters used quite a bit in the pharmacy. The metric system is based on units of 10, so it is very easy for us to convert between the different prefixes that we're going to take a look at. So for example, going from grams to kilograms or from milligrams to micrograms. And I'll show you guys some examples of that here in just a little bit. If you're not as familiar with the metric system, here are a couple reference units that you could use to kind of visualize the size of these units. So 1 gram is about the weight of 2 large paper clips. So really small amount of weight there. A liter is about the size of a quart, so roughly the size of a quart. We've all probably seen a 2 liter of soda, so half of that would be a liter. And then a meter is just a little bit longer than a yardstick, just a few inches longer than a yardstick. So, like I said, the base units that we see, so the base unit of weight is going to be the gram, the base unit of volume is the liter, and then the base unit of length is the meter. And then depending on what prefix we add before these words will indicate how far from the base unit we are going, whether that's going to be larger or smaller. And I will, like I said, show you some examples of that in just a little bit. So anytime we have a number less than 1 in the metric system, we want to make sure that we are using decimals rather than fractions. We always need to make sure we have a leading 0, which I'll show you here in a second. We want to have a leading 0, and we also want to avoid trailing zeros here. So let's take a look at what I mean by that. So if we have the measurement 0.25 milligrams, and I just leave this here, it's really easy to glance at this and think that this says 25 milligrams. Okay, so we always need to indicate a leading 0, a 0 going before our decimal point. Now, same thing, if I left off the leading 0 once again and I added this trailing 0, I could also glance at this really quick and see 250 milligrams, when in reality that's not the case. So always do a leading 0, never do a trailing 0. So these would be the correct connotation there for that. So some common conversions that you just need to begin memorizing here. 1 kilogram is equal to 1,000 grams. 1 gram is equal to 1,000 milligrams, and 1 milligram is equal to 1,000 micrograms. Like I said, no matter if we're looking at, grams, liters, or meters, we always start with a base unit, and then depending on the prefix, will indicate how much we're deviating from that base unit. 1 liter is also equal to 1,000 milliliters. It is important to note, sometimes you see medications written in cc's, which cc stands for cubic centimeter. 1 cc is equal to 1 milliliter. So we just want to make sure that we are using milliliters rather than cubic centimeters when it comes to interpreting the SIGs or the directions for our patients on our prescriptions. Now, before I get to the apothecary system, I want to go over some quick conversions using the metric system here. So here I have a number line that is indicating the most common suffix or prefixes that we'll use in the metric system here. And I'm going to show you how this number line works. So we always have a base unit. So that's either going to be grams, meters, or liters. So for example, let's say I have 2 grams and I want to know how many micrograms that is. Okay, so if I'm starting here at my base unit, I can see how many places I'm going to move to get from my gram to my microgram using that prefix. So if I'm starting here, I'm going 1, 2, 3, 4, 5, 6 places to the right. So I can actually move my decimal point 6 places to the right as well. So if we're starting with the whole number 2, my decimal point is going to be after the 2. And I'm going 6 places to the right. So 1, 2, 3, 4, 5, 6. And then I can just add in my zeros here. So 2 grams is actually 2 million micrograms. Now, we can do this going any way, starting from anywhere on this line as well. So let's say we want to now know, let's say we have 15 milligrams, and I want to know how many grams that is. So if we are, once again, looking at our number line here, we're going to start at milligrams. So we're going milligrams this way now to grams. So we're going to the left, 1, 2, 3 spaces. So starting with my number here, 15. Once again, if you have a whole number, your decimal point is after the whole number. So my decimal point is here. And we are going, make this a little bit bigger for you. So we are going from milligrams to grams. So like I said, 3 places to the left. So we're going to move that decimal 3 places to the left. So now 15 milligrams would be 0.015 grams. And always put in your leading zero there so we can indicate that as well. All right, so now the apothecary system. If you turn in your books to page 84, we're going to see most of these are probably symbols that you have not seen before, unless you're a third quarter student. So these may take a little bit more time to learn these abbreviations. Like I mentioned earlier, the apothecary system is the oldest system of measurement, and it's going to be the least commonly used today. We are going over this because some drugs are still measured in these units. So if you're looking at these units on page 84, we have the minim, the dram, and the ounce, and the grain. And then we also see the pound, so that's very similar to the household pound. And the ounce is very similar to the household ounce as well. So the ones that are newer to us is probably going to be the dram, the grain, and the minim. Now in the apothecary system, we always indicate the symbol before the number, okay? So the symbol will come before the number. And we also indicate any numbers. If they are less than 10, we indicate those in Roman numerals. Anything over 10, we can indicate in just regular numbers or Arabic numerals that we're used to. There are a couple exceptions here. They would like us to write the number 20 and the number 30 in Roman numerals. So just an example here to show you that. Let's say I have 15 drams. So the correct connotation or notation to write this in, well, we always put the unit before the number. So if you look at page 84, dram is written, it looks similar to a 3, just has a straight line on the top. So I have drams, and using those rules, this number is larger than 10, so I do not have to use Roman numerals. And it's also not 20 or 30, so I don't have to use Roman numerals. So this would be how I would write 15 drams. If I was writing 20 minims, well, my unit comes first, so looks very similar to an M with a little tail on it. Now 20, one of those rules says 20 or 30 needs to be written in Roman numerals, so I would write that as XX for 10 plus 10, which would be 20 minims there. Let's do one more. Let's say we have 7 ounces, and this is apothecary, so we're not using the household ounces. We're not using OZ here. So 7 ounces, the symbol would go first. So the symbol for ounces Looks very similar to the dram. It just has an extra little couple lines on the top there. So there's my ounces symbol. Now 7 is less than 10, so I'm going to write that in Roman numerals. So VII. So 5, 6, 7. If you're still struggling with Roman numerals, go back and take a look at chapter 3 for that. Okay, so minims are not used today, so we don't really see that anymore. Um, However, we do still see grains. So we see that in medications such as nitroglycerin, aspirin, codeine is another one. So we'll come back to that more in chapter 5 and 6 here. Um, Also, if we ever have a number less than 1, we're going to be using fractions. We're not going to be using decimals. And if we have a fraction that is 1/2, we can use that Roman numeral for 1/2 with, which is usually SS. Usually it has a line over that as well. So SS is going to be indicating 1/2. Now, I'm not going to be super picky on your notation for the apothecary system, but please do try to follow these rules in your assignment. I'm honestly more worried about, knowing how to do these conversions correctly rather than, writing the notations correctly. So here are some equivalents that you need to work on memorizing. So when you're working in the pharmacy and we are going to be, interpreting prescriptions all day, every day, we're going to need to know how to quickly convert between the household and the metric system. You don't see the apothecary used as much anymore, but we still see ounces used a lot. That's in both the household and the metric system. So start working on memorizing these now. I will post a study stack in Moodle that you can, practice training yourself to quickly learn these conversions. So we have equivalent of volume here, weight, and oh, I think that's all here. So just volume and weight. No length because we don't see that used too much here. So I am going to address these more in chapter 5 and 6 when we start actually converting between the two. So, like I said, utilize the study stack, make a table of your own if it helps you. It's really going to help you out in all of these chapters and just in the pharmacy in general.